one. This is find longest special substring that occurs thrice, number 1. Okay, let's go ahead and get right into it. This problem was released from the most recent programming competition on Leetcode. That's why it doesn't have too many likes or dislikes. It's a brand new problem. I don't really know how to classify this problem in terms of what category of data structure and algorithms it belongs to, right? It doesn't neatly fit into, dynamic programming or greedy or graphs or whatever. But with that said, let's go ahead and get right into the description. So you're given a string S that consists of lowercase English letters, okay? One thing to always note is usually you can leverage the fact that a problem is confined in terms of what exists within it. And what I mean by that is that this string only contains lowercase English letters. So that means it only contains all 26 lowercase English letters. Okay? And the reason why that's important again is that in some problems, the fact that there's such a small number of things that can actually be input result in kind of a refinement of the solution, which gives you a much better runtime, right? Because I'll know that whatever input I see, whatever character I see in this string, it's always going to only be one of those 26 letters, right? A through Z. Okay, a string is called special if it's made up of only a single character. Okay, special string equals composition of single character. So what's an example of that? Right, ABC is not special. Why? Because there's more than one character, one unique character, right? DDD and ZZ and F are special, right? Because this string DDD, it has only a single character, and that single character, it repeats 3 times, right? It's the number of unique characters, right? So this string DDD, if there was an infinite number of Ds, how many unique characters are there? There's 1, and it's that letter D. ZZ, again, that's ZZ top. ZZ is unique because there's only one, it's special because there's only one unique character, and F is kind of like an arbitrary kind of, technical special character because F alone is, how many unique characters are there? There's 1, therefore it's special. So that's really the question you have to ask. Don't think about the length. Well, you should think about the length later, but the idea is the length is irrelevant in terms of it being special. Just look at the string and say, how many unique characters are there? There's 1 unique character, therefore it's special. How many unique characters are there? There's more than 1 unique character, therefore it's not special, like ABC. There's 3 unique characters, not special. All right, return the length of the longest special, so we want the longest special substring. All right, longest special substring of S, which occurs at least thrice. Now, this might be unfair if you're not familiar with English enough, because thrice is kind of, it's not even I guess probably in the dictionary, but thrice is like once, twice, thrice. Okay, it happens once, it happens twice, it happens 3 times, you say that's thrice. So we want to return the length of the longest special substring of S, which occurs at least 3 times, or -1 if no special substring occurs at least 3 times. A substring is a continuous, non-empty sequence of characters within a string, right? So you go to left pointer, you have a right pointer, you cut it up, you cut both sides, you pull out the string, that's your substring, right? So we have to create a special substring that occurs at least 3 times. Okay, so when we look at AA, right? So example, we have S equaling AA. Well, what kind of substrings do we have here anyways, right? Well, we have this whole thing that's special, right? Because there's 4 A's. And then we have 2 3's here, right? There's this 3 substring and this 3 substring. So we have 3 A's. I'm trying to think about how I'm going to dictate this. Let's say for A occurring 4 times, that happens once, right? And that's this. For A occurring 3 times, that happens, I'm all over the place today, guys. I apologize. A happening 3 times, that occurs twice. That occurs twice. What about A occurring 2 times? Well, there's this A twice, right? Because I can split it up multiple times. So A. So that's A occurring 2 times, happens 3 times. I'm all over the place. And then what about A occurring once? Well, that's the single. So for A occurring once, there's 4 times that happens. Right, and you can kind of see this 1, 2, 3, 4. Why does that happen? Well, because, sorry, I just thought about a different solution to this problem that might actually be better, but I'm not going to go down that rabbit hole right now. But Right, this happens once. If A happens 4 times once, then it happens 3 times twice, and 2 times 3 times, and once 4 times. If they're in a row, right? Because if there's 4, well, to make 4, I can make a 3 and a 3, right? If I have 4 characters together, let's say B, 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 B. Oh, no, they're all lowercase. So let's say I have C, 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 right? Well, if there's 4 together, well, then I can create 3 together by making this substring and this substring. Right, if there's 3 together, I can definitely make 2 together, right? Because I can make C and C, but I can do that for these 2 here, right? So you see how this kind of, I don't really know if there's a larger statement you can make about this. Really just the fact that, okay, if you have 1 that's 4, you'll definitely have 2 that's 3, and 3 that's 2, and 4 that's 1. Yeah. So what's the answer here? Well, the answer here is 2 because, well, we can create thrice, right? We can create the longest substring which occurs at least 3 times is this A2, right? Because we can create AA, 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 and that happens, AA happens 3 times in this string, so it's the longest substring that can occur, right? So that would mean that this answer is 2, right? And you might say, well, why is it not A equals 1, A1, 4? So, you know, 1A of length 1 happens 4 times, so it does happen more than thrice, but it needs to be the longest one, right? So we can't pick this one. Even though this is a special substring, it only occurs once, and it needs to occur twice. We can't choose this one, because even though there is a longest special substring that's longer than 2, it only occurs 2 times, right? So, you know, we have 2 of length 3, but it needs to be at least 3 times occurring. The largest thing that occurs at least 3 times is 2A's, right? This occurs 3 times is the largest thing. This thing occurs more times, but it's smaller, right? So you gotta have these like balancing things, right? We want to maximize the size, but it has to happen at least 3 times that we see the thing. Okay. This is an example where nothing occurs at least thrice, right? Because, you know, it doesn't really notate it that well. I guess it kind of does, but like, you know, we have A, B, C, D, E, F. So it's all unique. We don't have anything occurring more than once, right? We have the special string A, the special string B, the special string C, the special string D, special string E, special string F, but none of them occur more than once, right? So it needs to occur at least 3 times. Okay, this one will show you A, B, C, A, B, A. Right, another example here. So the answer is 1. Why? Well, because there's this substring 1, this special, this special. There's this. These 2 are the same special one, and this one, right? So A1 in this example occurs 3 times, B1 occurs twice, and C1 occurs once. So the largest thing that occurs at least 3 times is this A1. So then our answer is, you know, this value, which is 1. All right. S length is less than or equal to 50. So really, it's so small, you might actually be able to get away with, well, you could get away with actually a pretty inefficient solution, right? A non-optimal solution because the input is so small. But that doesn't necessarily mean that there isn't something faster, right? And there's a lot of good videos, and I've said in previous videos, maybe I should make a video about constraints and what the implications are, because it's a really good trick to kind of optimize, to determine what your optimal solution should be, could be, would be, etc. But basically, you know, this means that we can get away with something bad, but that doesn't mean that the bad solution that we get away with is the best solution. That's kind of the point that I'm trying to make here. So what do we do to solve this, right? Because it's kind of a complicated scenario here. How did I even solve this, right? Well, I guess the thing to think about first, that I first considered, was the fact that it's only lowercase letters, right? So we only need to keep track of unique substrings for A through Z, right? And I guess maybe the first thing we should think about is how would we find the unique substrings within this system, right? And what would that mean in terms of like where the special substrings are, right? So how do we find special substrings when we look at, you know, I don't know, A, B, A, C, A, D, D, A. All right. Maybe this is way too long of an example, but you know, when I want to find longest substrings, I can look through this and I say, okay, I start looking through the system and it has to be a substring, so it has to be continuous, right? So maybe I'll represent this as a graph, even though it might not be that useful. And I do apologize because now this video is kind of getting away from me, because this is definitely one of those problems where, you know, it's more intuitive than it is explanatory, right? But that's okay. So if we had A, B, A, how would this work? Well, when I look at this A, I say, okay, this A alone is a special substring. So maybe I say A length 1, I have another substring, right? Then I look at B and I say, okay, B can't attach to A, so there's no A length 2 thing. But I could say B length 1, there's another substring. Then I look at this A, I say, okay, look, there's another new A of length 1, so this becomes 2. And then when I look at this A, I could say, well, there's this A alone to make this length 3. But there's also now going to be an A of length 2, right? A of length 2, there's one A of length 2. So the way I could do that is I could keep track of the longest thing as I go forward, right? I say, okay, the longest thing ending at A here is 1. The longest thing ending at B here is 1. The longest thing ending at A here is 1. And when I attach A to A, right? So when I attach these values together, what I'll really do is add 1 to this value, and this will become 2. So then I can note that there's an A of length 2 and add that to my ledger. Then I look at C and I say, okay, for C, can I attach myself to the previous thing and make a longer one? No, I can't, because the longest thing here is 2. But even though the longest thing here is 2, it's not the same character, so it won't be a unique special string anymore. So this will stay 1. Then I look at A here. I try to connect it. I can't, so that means C1, I add 1 to that. A1, I get another 1. Here I get link 2, and I get another. Let's actually modify this, just so you can see this, another step of this in practice. Always good when the examples aren't sufficient to make your own example and kind of massage them and modify them as you're going to try to see kind of edge cases, how things change, right? Don't make it super simple. Of course, don't make it so complicated that you can't even solve it. You spend all day trying to do an example, right? But don't make it so simple that it doesn't reveal anything. Just make it, you know, it's kind of a flexibility thing, right? You need to find that right spot in an example that you create where it kind of shows you something about the problem, but it also doesn't exhaust too much time. Okay, so A2, now I have another A2, so this is 2. Now here I'd get A3, right? Because I attach myself to this. I say, okay, is my current thing equal to my previous thing? Yes, so I add 1 to whatever that longest length is. Right, and then I'd have to add 1. Well, now I get this A alone is 1. Now with these 2 A's together, that's another 1. And then with these 3 A's together, that's a new 1. Right, so this thing on the left that I'm trying to create is kind of just a ledger of what I'm seeing, right? Then I look at D and it gets reset, and I have a D1. Then I look at D here, and I'd say, okay, well, this D alone will give me another 1. And I have D2, so that means D2, I have 1. And then another set of AAs. But another set of AAs here will give me another set of these, which will get this to like 5 or something, or 4. And this would be 6, 7, right, going up. Right, so then all I would have to do is look at this ledger and say, what's the maximum thing I can get? This is so sloppy, I apologize. Right, but I look at my ledger and I say, what's the maximum thing I could get that would maximize my score here, right? Like, okay, I'll keep track of all the things that I've seen so far, right, as I go through the system, right? So I can look at all these and say, oh, I got an A3 here. How many of those do I have? No, that's not good. That's only 1. Oh, I have a D2 here. How many of those do I have? Oh, I have 2 of those. How many of these do I have? Oh, I only have 1 of those, right? I look at A2 here and I say, oh, I have 5 A2. So that's more than 3. So I can call A2 and that would be the answer. So I'd return this 2. That's all over the place. So let's walk through this one more time, a little bit simpler, and really make this work, right? So that's me kind of reasoning through what I would do to like just scratch my way through like, how the hell is this supposed to work, right? But let's think about how you would do this now that you have an idea, okay? So we need to try to find the special characters, okay? So we want to find all the special, find special substrings. We want to find special substrings, and we want to keep track of maximums. All right, so what I mean by that is I'll have this ledger, okay? And in this ledger, I'll keep track of the character, the length, and the number of times it's occurred, okay? And it'll look like that. And I'm also going to introduce this little L as like a current longest. That way I can always keep track of, you know, how long are these perfect substrings that I'm creating. And if I add something and it makes it not perfect anymore, I'll reset L. All right. So if we had the example AAA, BC, AAA, DEA. All right. So I'll keep track of this longest here, and then I'll just start building through. So the first thing I see is an A, and my longest is going to start initially at 0, okay? So I'll say, okay, my longest is now 1, and I'll say A at my longest value L plus equal 1 equals 1 now. Then I go to this next A, and I say, okay, can I attach myself to the previous thing and stay special? Yes, I can. So this would become 2. So now I have a case where I have A2, and that equals 1. And I can also say that, well, this A alone, if I can create something with 2, I can also create something with 1, right? And 3, you know, and so on and so forth. So that means that this becomes 2. And I'm going to cross it off to signify that I'm modifying this. I'm going to move this over so I have more space to modify. All right. Now, when I see this next A, I'll say, okay, can it stay special if I attach myself to the previous thing? Yes, I can, because A equals A. So this becomes 3. So then I go here and say, okay, well, that means that A3 equals 1. But if I can make an A3 equal to 1, I can create an A2, and I can create an A1 by itself, right? Because I can make this one a 3, and this one a 2, and this one a 1, and I haven't accounted for that yet, right? So what I can basically say is, well, when I attach to this one, and this point is kind of irrelevant because in a moment I'll show you how you can kind of remove this information, right? But I have this A, when I attach this A, I can do this A alone, right? So that would mean I'd have to cross this out and increase this to 3, right? But I can also attach these A's together, right? So I have to cross this out and make this 2. And then I can actually do all 3 of these together. So I have to cross, well, I already did this one here, right? So even though I get 3, I add 1 to 2, and I add 1 to 1, because that 3 was created using 1 plus 2, and that 2 was created using 1 plus 1, right? So in order to get 3, I had to get 2. In order to get 2, I had to get 1, right? And then I continue down this road, right? So now I look at B. Here's the first example where L is going to reset, right? Because I attach B to A, and I say, can I attach B to A and stay special? No, I cannot. So this becomes a 1 again. So then I create my ledger, B1, 1. And I just go down that path all the way until the end, until I find the longest substring I can create of length 2. So I'll do it really quick, okay? So C1, length 1, A1. Now this becomes, I'm going to run through this whole thing. 1, 2, 3, 1, 1, 1. All right. And then what does that do to this whole problem? So I get to A2, so that becomes, this becomes 3. But then this also becomes 4. Oh my gosh. I get to A3, that means that this becomes 2, but then everything else gets populated down too, right? So these 2 are going to get increased too. Right? So this becomes 4, and this becomes 5. And then DEA. So I get a D, I get an E, and then I get another A. And that will run me through this whole system. All right, so now what the problem comes down to is, well, I look at my ledger, right, and I say, okay, in my ledger, what can I do? Well, I can look at I maybe should sort by my destination keys and say, okay, what's my largest thing? I have 3. Can I create at least 3 special substrings of length 3 with A? No, I cannot. I can only create 2. So maybe I look at B1, C1, D1, E1. I say, okay, none of these even work. Oh, I have A1. That works. But it's actually, is there something better? Well, the best solution here would be this A2, 4. So my answer would be 2. Okay. Now, one thing we can do to simplify this problem is that it's kind of implied if you have something of length 3, you can also create something of length 2. So do you even need to notate for that? Do you even have to account for the fact that, oh yeah, if I make something of length 3, I can also make something of length 2 and length 1, right? Because that's what I kept having to do, right? I made something of length 3, for example, then I was like, all right, now I got to update 2 and I got to update 1, and I kind of had to go down the path to update, right? But the truth is that there's kind of intrinsically something of length 2 with length 3, and you don't really need to account for that. And what I mean by that is the following. So I'm going to do this problem, and there's going to be a slight modification, and you'll see that, well, it actually becomes much simpler. It's going to become much quicker, and, it's just going to be less of a headache. So I don't need to actually copy this whole thing. I just need this. Right, so what I'm saying about the intrinsic fact of this problem, the intrinsicity, is that even a word? The intrinsic reality of this is the following. So I'm going to make my ledger again, but I'm not going to do that back propagation thing, right? Well, it's like when I updated this to 2, I had to update this too, because it always happens. So there's kind of like an intrinsic truth to that. Okay. So let me do this again with a slight modification. All right. So my new ledger. All right. So my ledger is 1. So I'll say, okay, I'm still going to do this. A1 is 1. 2, I'll just do A2 is 1. 3, okay, I'll do A3 is 1. B is 1 again. B1 is 1. C is 1 again. C1 is 1. A1 again. That's the first update. 1, 2. A2 again. Another update. A2, 2. C3. A3. A3, another update. A3, 2. D1, 1. E1, 1. And then A1, 1. A1, another one. A1, 1, another one. So look at how much simpler this is now. And you might say, well, the answer is 2, and your ledger says that A2 only occurs twice. Right? So you're like, well, this doesn't work, right? This is obviously much simpler, right? I could just run right through it. There's not all these updates and like back propagating updates. So how do you capture that in this reality? Well, I'm trying to maximize my score, right? So if I look at A and I say for A, I can get A3 twice. So that's not quite enough, right? I can get A3 2 times. Okay? So then I go to A2 and I say, well, I can create A2 also 2 times. But the truth of the matter is, well, these A2s, when were these accounted for? They were accounted for this string here and this string here. Right? And these A3s, when were those accounted for? Those were accounted for this string here and this string here. All right? So even though A3 doesn't occur at least 3 times, I know that A3, in order for A3 to happen, there has to be an A2 that connects. In order for A3 to happen, there has to be an A2 that connects. Right? That's different than the A2 corresponding to the ones that I logged as 2, right? This AA is a unique substring from this AA, right? They're counted as separate instances, right? So in order to create A3, I had to create an A2, which is different than the A2 that I logged here. Let me say that again. when I created this A3 as 1 in the beginning, for example, it's this substring here, right? A, this 3. And when I created this A2, it was this substring here, A2. But to create this A3, this green A3, there's another substring I didn't account for that has to exist in order for this A2 to exist, and that's here. So all I really need to do is start at A3 and say, okay, can I create at least 3? I need to create at least 3, right? Well, unfortunately, I can't create 3 here because 3 only occurs 2 times. But that means that in order to create that 3, I had to create 2 the same amount of times, right? Every time I created this 3, there was this 2 inside, right? Whenever I create an end length special string, there's an n-1 special string that exists that I'm not accounting for that has to exist in order for this n length string to be accounted for. Okay, so even though I need, 3 times and I can't get that here, well, that means that I already got 2 times using this. So this can become 1. And this can become -1. So then I know that I can get the maximum of 2. Okay. And then let's do that really simple problem with this example again. And maybe you'll see it a little bit more clear. More clearly. Claramente. All right. So ledger is 1, 2, 3, 4. Right, so that would mean that our ledger is A1 is 1, A2 is 1, A3 is 1, A4 is 1, right? Because I would go here and I say, okay, A1, 1, A2, 1, A3, 1, A4, 1. So my largest is A4. So in order to create an A4, that means that everything above here, right? Like before, we would have to update this because these are all B substrings that we didn't account for. So I know that in order to create A4, I'd have to create another A3, another A2, another A1. So that means that whatever my solution might be, even though it doesn't work for 4, I know when I use 4, or I start with 4 where K, I have to have at least 3. That means I can at least get one of whatever smaller. So then my K becomes 2. Right? Then I look at 3 and I say, okay, well, in order to create 3, I'd have to create another 2. So my K becomes 1. In order to create 2, K equals 0, so I'm good. Right? Because what I'm intrinsically accounting for doing this is I'm intrinsically doing the following, right? If I have to create a 4, right? So that's the process. But what I'm in red, I'm going to put not what I log, but what I understand, right? What's implicit is in order to create this 1, that means that there was 1 more of everything below. Right? In order to create this 3, there was 1 more of everything below. In order to create this 2, there was 1 more of everything below. Right? So I'm capturing this 3 by just the fact that every time I create something, there's something 1 below all the way going up. So instead, I can start at the maximum thing, subtract that from my solution, go to the next maximum thing, next smallest maximum thing, and subtract that from my solution, and just keep going up the row like that. Hopefully that makes a little bit of sense. Okay. All right. This is for the photo, I guess. All right, so let's go ahead and code this bad boy. So we'll create our ledger. And I'm going to create it as 2 default dicks. You're probably going to hate the way that I'm doing this. And I do apologize. All right. And the default is 0. We're going to have our current count as 0. And then we're going to have our past character to compare to. So we always know, like, do we equal our past character so then we can add 1 to our system, right? So current character, past character, I'll call it P equals -1. So just to start, we'll look at all characters in S. And then we'll play this following game, right? We just walk through. We're literally just going to code up what we just did, right? So what I did is I said, well, L is going to get increased if what? L equals L plus 1 if the current character I'm looking at equals the past character. Otherwise, L equals 1. All right, so I'm basically saying is, all right, I add 1 to the longest special string before if it keeps it special. But if it doesn't, if they're not equal, then now the longest special string is just me, myself, this single character. And then we set past equals character. And then we just update our ledger. So we say L at the character at this length, L plus equal 1. And that's it. And actually, I could set this to C here. There's a lot of, I could probably do more bogus to make this even shorter, but that's already ugly enough. All right. Now I just need to find the longest, right? So the K length that I need is 3. I'll set res to -1, and at the end I'll return res. Now I could look at all things through the string, right? But since I'm kind of like counting down, I should look at each letter. And since there's only 26 letters, it's not going to spiral out of control. But I look at each letter, and then I'll go down its list from the maximum number of times that it was counted to the minimum, right? So I'll look at each character. For each character in this range, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. This is actually where K equals 3. And then I'll just go from the range for I, only if, I guess I should make sure that the actual character exists, right? There's actually, so if this character exists, or no, I don't even need to do that. I could just say L.keys. So I don't need to do that. All right, so I'll look at all the letters that I saw that I accounted for, and then I'd go in the range from the maximum number of times that it occurred. So that'd be L of C all the way to 0, -1, right? So, because if it occurred 4 times, there's not going to be anything in between, right? If it occurred 4 times, then it had to occur at least once 3 times. It had to occur at least once 2 times, etc., right? And then I'll just say K minus equal the number of times that it occurred here. And if we get below or equal to 0, that means we did our job, right? So if K is less than or equal to 0, well, then that means we found this sequence enough times, right? Because the higher up, we implicitly pulled that out, because in order to create a higher up number of length, we'd have to get to this length. So we'd say res equals the maximum of whatever res is for maybe some other character, and what the length is that we're looking at, L. So we'll call this L here, actually, because it represents length. And that's going to be as big as it gets because we're going downwards, right? So since we're going down, if we get an answer, anything that we find subsequently would only be smaller, so we break. And at the end, we just return res. All right, now what's beautiful about this problem is I have no idea, really, what the complexity is. Seriously, because it's a little weird. All right, so this right here is just O of n, right? So let's figure this out. So C equals, let's say n is the length of S. This is O of n, right? Because I have to look at all the characters. This, in the worst case, could be O of n if they're all unique. And then we have to go from the range at the longest that something exists. So the longest number of times it exists to the minimum number of times that it exists. The longest number of times that it could exist. Oh, I don't know. I really don't know what the complexity of this is, guys. This is so weird. Somebody tell me what the complexity of this is, because the time complexity is an issue. Because this could be at most 26. Right there, because there could be at most 26 keys. All right, well then this is 26, right? Because there can be at most 26 unique keys. Right, so that's the beautiful thing about this being lowercase letters, right? There's at most 26 lowercase letters. And then here we go from the longest length of the string to the shortest length. So this is maximum the whole length of the string, right? Because maybe the whole string is one character. So it's like the characters, if the string's length is n, this will go from n to 0. And if it's not, then in any other case, it'll be some, so this is O of n in the worst case. And this is 26 in the worst case. So that's 26n. So this is n, this is 26n. 26n is just big O of n. So that means the time is, this is one of those ones where my hands are shaking. Like, I don't even really know. This is, I think it's O of n. Please someone confirm that. Okay, what about space? Also weird, because we create this dictionary. And there can only be 26 keys in it. But within 26 keys, there can be a reference for each string. So that's also O of n. All right, guys. I hope you have a beautiful rest of your day. Please, someone tell me if this is right, because this is a little bit confusing, the runtime space complexity of such a kind of complicated problem, like with a break and, when those kind of things happen, it can get a little tricky. All right, peace out.